Yes. Today topic is epicycloid in engineering graphics. Here is the definition for epicycloid. The cycloid we already know. A roller rolls on a flat surface. Here the epicycloid, the roller rolls on a curved surface. Here is the definition: when a circle rolls without a slip around the outside of a fixed circle, and we are locating the locus of a point on the circumference of a rolling circle. So, for suppose if I take here, it is a rolling surface, here is a roller, it rolls on this surface. This is a curved surface. We call it as a directed circle or directed curve or a base circle, and the roller we call it as a generating circle. Here is a problem to draw, how to draw epicycloid. So, draw the epicycloid given the radius of rolling and directing. Here the rolling circle which rolls on a directed circle. So, here the radius is r is equal to 25 mm and the capital R is equal to 75 mm. First we have to know the how the rough diagram will be for epicycloid. And this is the surface of a directed circle, and here is the rolling, and the curve is like this, and that is a basic rough diagram for epicycloid. So, here we have to find the theta between these two generators, and the theta, it comes, theta is equal to small r by capital R into 360 degrees. Here is the how we are finding out a theta. So, what's the value of r and capital R into 360 degrees. So, that I am substituting here, the value of small r is 25 and here it is 75 and 360 degrees. So, while we are calculating this, we just try to calculate this 25 by 75 into 360 degrees. The how much the angle that we will get, the finally, that is 120 degrees. So, here the theta angle between these two generators, that it is 120 degrees. So, let me start from here, somewhere, anywhere on the drawing sheet on a paper, that we just imagine a point. From there, we have to take the radius of small r, it's a directed circle, and small r is the roller radius and the capital R is the directrix. So, we have to take here the capital R, the radius is 75 mm. So, I am taking with a radius of 75, and here it is the dimension lines. And it is value of capital R, that is equal to 75. From there, and here it is a center O. From here, that we have to try to draw an arc, and that is a directed circle. From here onwards, that I am taking a next end generator, that the angle is theta, that is 120 degrees. From here, that I am trying to take a 120 degrees angle. So, here it is the curve, the curved surface. From here, on this curve, there is a roller which rolls on this from here to this end. So, I am trying to draw a roller. As corresponding to this line, that I am extending with the 2.5 centimeter, because the roller radius is equal to 25 mm, that we have a 2.5 centimeter radius. And this is an axis, vertical axis, As I am now taking a perpendicular to this is a horizontal axis that we are not considering later. Only that we have to consider this horizontal axis for division of this circle. So, the division of the circle, as we all know that the 12 parts, how much the angle circular angle is 360 degrees. While we are dividing these 12 parts, each angle we got how much? 30 degrees. So, that I am taking here it is 30 degrees and here it is 30, 30, 30. As we know that whenever we have a circular concept, we have to divide 12 parts because it is easy to locate a locus of a point and we can easily join it. So, this is the way that we have to divide a circle. The later that we are not using this line, horizontal line. Then after, we have to take a number, that is here it is 1, 2 and this is 3, 4, 5, 6 and 7, 8, 9, so 10 and it is 11 point. Like this we have to make a numbering for this. Then after that we have to divide this, how much the angle it is, theta is equal to 120 degrees. So, that I am to divide this 120 degrees into 12 parts, as we know that each part will get 10 degrees, 10 degrees. So, 1, 2, 3 is a 4, is a 5, 6, 7, 8, 10, 11 and this is the 12th one. So, I am taking here the number 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6, 7, 8. As you can join this 0, 1, no problem. This is 12 dash and here it is actually it is 6 and this is 7, 8, this is 9, 10 and this is 11 and this is the point 12 which is on the roller P. The P is a point on the roller that we have to trace the point. Then after that we have to consider this 1 dash will join with the 1 and 2 dash will join with the 2 and 3 dash will join with the 3 while it is rolling on this curved surface. So, there is no problem that you can join 1 dash and 0, 1 dash 0, 1, 3 dash 0, that you are making a divisions on a curve. And after that take a O as a center, join, here I have a 11th point and here I have 1 point like a curve. 0 is a center, 0 as a center, join 11 and 1 like a curve. And the 10 and 2 is like a curve. And here we have a center, that it is curve arc dot arc dot arc dot arc, like this. That is a center axis and we are trying to join 3 and 9. In a cycloid 3 and 9 we have a center line, but in an epicycloid there is a different curve and the center is also a different curves. And after that, these are all curves which comes from 0 as a center, that we have to extend it, we have to place a needle at 0 and we have to extend 11, 1, 10, 2, 3, 9, 8, 4. We have to extend the compass. Then after 7, 5. It will happen by using our engineering compass, not with a regular compass, because it's a distance is very large. So that we have to assume and you have to consider and you just make a measurement by the engineering compass. Then only it will get a exact curve. So this is the way how we are creating a surface. Then after, have to point centers, and here is the center which we got C naught, and this is the central axis that what we got in a previous, right? Exact that we are extending line up to here, and this is C1. So I will try to give a one example at here. As exact, I am joining that 0, 1 dash and to the center line. Like this we will get a exact center line. While it is rolling on a curved surface, the center also replaced at everywhere, so that the point P also will replaced. So the point 1 on the circumference of a circle roller will touches the 1 dash while it is rolling in a 1 dash, and then second roll the 2 will touches with the 2 dash. As I'm same, we have to repeat 0, 2 dash and extend it up to here, and this is C2 and C3, and here it is C4, and here it is C5. I am giving an example that how we are joining a center lines, and this is C6, and this is C7, C8, C9, C10, C11, and exacted here C12. These are the centers we got. As same as in a cycloid, in an epicycloid, that we are taking a radius of the roller is 25 mm. That means 2.5 centimeters. And take C1 as a center, measure the distance of roller, that is 25 mm, that is 2.5 centimeters. With the compass, 2.5 centimeter, that is a common distance. And the C1 as a center, draw an arc on 11 and 1 dash curve. Here we got a intersection of arc and a curve. And again we are repeating that with the same distance 2.5 centimeter, the C2 as a center, draw an arc and 10 to curve. And as same C3 as a center, draw an arc on 9 and 3. Here the 9 and 3 curve is different and the center line is different. In a cycloid, center line and 3 and line is same. So C3 as a center, 2.5 as a centimeter, that we have to take a one arc on 3 and 9 curve. And we can make a name for this P, for suppose as a Q is a R. Like this, you have to repeat it. C4 as a center and C5 as a center, and as well as C6 as a center, exact at top, here we get U. And these are all in a left side, and the remaining curves will come on a right side. Then you just go through this. And like this, that we will get the values, the names, so that we will get arcs on every curve in the left side and right side, So these are the curves that we have to join in a freehand. This is the only curve which we have to make a highlight, because our aim is to locus the point on a circumference of a circle or a roller. This is the curve which we get. for a epicycloid while a roller is rolling on a curved surface. So, thank you.